So robot tunjuk lah sebenarnya. Itulah dia macam dekat robot ni bukan semua. So media kita ada objektif lah. Objektif kita ni kita sebenarnya nak bekerja rapat dengan industri. Bila kita bekerja rapat dengan industri, actually bukannya ilmu tu saja keluar, kita gain a lot. We gain a lot and we can give more. Okay, so kita banyak isu-isu kat industri dengan universiti, selalunya dia tak nak. Tapi dekat CIP kita boleh. Sebab we listen to what industry wants and industry listens to what we want. Industri sangat laju lah kan. Teknologi universiti ni, kita tak boleh tukar-tukar syllabus ke hati kita. Jadi we try to adopt. Ada banyak postgraduate students lah yang akan come up with penemuan-penemuan teknologi ataupun application teknologi. So, biasanya kalau di universiti, I think universiti bersama, kita selalu fokus teknologi readiness level 0 to 3. 0 to 3 tu research, teori, ideation, simulation kan. Tapi dekat sini kita melampaui. Kita go into prototype. Jadi, lecturer-lecturer yang dah ada idea, dah ada small basic simulation, basic theory, apa dia akan buat? Kita. Prototype, it can be either industry based, or education based, or community based. So, community based ni maknanya kita tolong orang-orang you lah. Saya, I work very close with blind and autistic children. Kerja saya adalah menggunakan teknologi untuk membuat peralatan yang diperlukan oleh pelajar-pelajar. So, blind children, dia understand lah, dia tak nampak kan. Dia tak baca kerja kita. Kita tengok, tak tahu kan. Mereka menggunakan senses lain. Hearing, touch, kan. So, we work on that. So, we use technology so that they will be able to learn just like kids who can see and hear. Okay. And then, ada juga lecturer yang go into prototype system. Okay, this is with very long collaborations with industry. Okay, and then kita work up to commercialization. So, kita banyaklah grant commercialization industry, grant commercialization dengan kementerian. So, we use a lot of funding from the government and also from the industry. So, sometimes we have matching grants. So, industry comes up with maybe $500,000, the government comes up with $500,000. So, biasanya Dr. Hanafi yang terjun lah. So, it's not here today, so So, our base is, the director is Dr. Zul. Me as a director. And then we have other lecturers. It's not with you, Dr. Imran was here, Dr. Jazlan was here, Dr. Hanafi was here, Dr. Azami was here. And all of us in CUBE, we have about 25 of us, 5 people. So, we coordinate this lab. Okay, kita ada embedded AI lab, kita ada maritime robotics lab. Nanti you nampak lah di swimming pool yang angkatan tinggi ni, kita testing robot-robot di bawah. Kita ada mocap lab. Kita mocap lab. Kita ada robot design lab. So, robot design lab ni basically students lab lah. Students working space. Macam guna Arduino, guna Raspberry. So, dia bina robot kat situ. So, these are our robotic students. Hari tu, last year UPSI ada hantar tim kan ke Robocon. You all terlibat? Senior lah. Senior. Yeah, I saw UPSI's robot. So, I'm surprised that UPSI wants to go through this, which is actually very good. It's motivating for your students. So, kalau cikgu suruh student pergi competition, cikgu kena pergi competition dulu. So, it's a good experience. So, kami dulu pun bukannya terus the robot sendiri, memang from scratch. It's a very good learning experience. So, kalau kita pergi robot design lab, dan then satu lagi, kita dah grant kementerian, robot lab, makeup IUM lab. So, lab ni, lab kita bayangkan ada seperti an empty space. We bring in people to handle workshops. we train our trainers. And then we send our trainers to di sekolah orang asli, sekolah orang buta. Kami latest ni pergi sekolah bimbingan jalinan kasih. Siapa pernah dengar? JK, sekolah di Turki. So we try as much as possible to reach everybody. Tapi we focus on orang asli, SPJK dengan disability. Sebab selalunya these are underserved communities lah. Kan? Kalau pergi SPJK, pergi sekolah orang asli, semua cikgu kena buat. Kan? Macam sekolah, cikgu kena buat. Sekolah kebangsaan biasa, maybe you ada tukang kebun. So, sekolah macam tu kadang orang tak ada. Sebab mungkin bajet lah. Tak tahulah. So, kita ada team, robot team yang besar. Kita buat 100 plus students. So, they are very active in competitions, in training, and giving training. Okay, so these are our team. So, about 80% of the department of electronics lah. And then followed by mechanical and electrical. And then baru ICT. Kita ada juga ICT. So, Q ni bukan kuliah engineering saja. Kita ada juga yang daripada kuliah lain. Kuliah is fakulti. Kuliah kat UAIM, kuliah is panggil fakulti. Dan fakulti is called kuliah. So, that's us. So, what you tadi masuk meja sini. Sekarang ni you see. So, you kat sini. Q dekat sini. Dekat bangunan T2. Sekarang ni kita tengah T1. Kita ni macam dekat sini lah. Nampak sini tadi ada T1. Kita atas. So, ini adalah kolam. Ini kolam. Ini kolam ni. So, ini gambar-gambar masa kita launching. Okay. Kita launching itu. Lepas launch, minggu tu COVID. So, banyak work from home lah. Banyak design semua. Yang brothers, lecturers yang guys, orang nyuruk juga lah datang sini. Buat baby work, face shield untuk our staff workers. Macam mana yang dipakai ni supaya tak terjangkit. Ada yang buat robot untuk deploy di hospital. So that nurse pergi ambil suhu, pergi ambil tekanan darah, semua robot boleh buat. Tapi biasalah robot tu is still in progress. Kita dah sampai level, dah sampai prototype yang keempat. Sure whether you can have a view of the network. So this is our labs. We have about 9 labs here, 9 spaces. Okay. And me, some of my work dengan startup lab working on disabilities. So this is the research we done in 2022 actually was for something else. Cuma kami accompany UMP untuk visit kilang, lawatan ke kilang untuk melihat bagaimana di Jepun orang kurang upaya join sekali, kerja sekali bersama orang-orang yang biasa, orang normal. So that means you will see people with wheelchair, people with anxiety, people with autistic, ASD, blind persons working in spaces, factories in Japan. Jadi kita semasa kita cuma nak study dia punya topi. Balik Malaysia, try to propose lah for the industry Malaysia. Sebagaimana kita tahu, industri di Malaysia not really welcoming lah. Not really welcoming OKU. In fact, IPTA pun tak semua sepenuhnya welcome orang OKU. Banyak restriction. But we are trying to bring these policies. So that was the initial idea. Somehow it became an engineering idea where kita cuba buat. Kita lihat apa masalah yang ada di sana. Orang-orang yang gunakan wheelchair, kita punya pos Mujika, student college. So dia memang dia director of disability unit, disability students unit. Kerja mengajar je satisfactory in work tak ada tau. So I have to do something to help people. Kita nak buat research canggih-canggih, nak buat roket pergi bulan tak boleh. Tak ada duit kan. So we do other things. Because the person who, because this is a real case story. Orang ni dia tak ada rotator cuff, he's a draftsman, dia boleh case draft, sampai plan kot. So first thing about orang yang disabled ni, dia murung. Dia akan murung. Especially kalau dia kena minta tolong ramai kali, dia murung. And guys, it's a guy. Guy especially lah, dia ada ego dia. Betul kan? Betul tak? Kan? You have your pride. So, I mean, woman pun ada, but woman dia masih lagi kadang-kadang dia tahap redha dia tu tinggi sikit. So guys, so he's the breadwinner. So bila dia tak boleh kerja, so everything dia macam snowball lah. Everything falls. So when we propose this to him, dia macam ada, oh, there's something for me. Tapi yelah, it still takes a long time. So kita takut juga nak letak atas dia, takut kan salah apa programming ke apa kan, nanti lagi teruk kan, dia ke belakang ke kan. So for that we bought a mannequin. Susah tau nak cari mannequin yang ada tangan. Selalu mannequin kat kedai kan tak ada tangan. Kita nak cari tangan, lepas tu tangan yang boleh gerak pula tu. So but we managed to get one. It was 500 ringgit. Yalah, tapi we got it lah. So the next step is we are still looking into possible collaboration with this particular company. So they're very supportive on research. So what happens is when we go out, we tell people what we want 20 times, 20 different organizations. Tak peduli. Pergilah yayasan mana pun, sebut stamp. Buat apa? Sebab kita bagi stamp yang mahal apa? Makan, travel, lodging. Robot kita kecil je. Kita ajar Arduino tu bukan besar sangat pun. Dia nak kita buat projek 100 computers kat sekolah. Sekolah tu dah ada komputer, what for? Dia need club robotik. Dia nak tutor in robotics. So we go there. So 20 yayasan might not want it. The next 20, daripada 40 tu mungkin ada 2. So kita dekat queue tu memang keep on proposing. And Alhamdulillah, with the schools that we go to, the teachers are also very supportive. So kalau cikgu tu nampak ada leeway nak dapat sikit, nak tak okay, kita nak bagi duit lah, boleh tak kita buat. So dia orang, because they know there's somebody to help them, so dia orang pun work together lah. So we work hand in hand. Okay, alright. So actually what I'm supposed to deliver is this. Okay, so your lecturer gave me a very extensive list. And saya rasa you dah travel jauh-jauh ni, takkan nak tengah saya buat calculation kan? Kan? Saya pun, so I left out all the calculations. So you don't have. Sebab nanti hujung-hujung kan adalah quiz sikit. Tapi quiz saya senang-senang je. So saya hari ni what I want to share with you is not really teach, share a bit of my knowledge, a bit of what we have. So, because I'm from the Department of Mechatronics, we deal with robots. There are so many people work on robots, but not necessarily they build that robot. Okay? Some are on the AI part, IoT, and some are on the sensors and actuators as me. Some are on the dynamics of the robot. Kira angle, some programming. Some test on human acceptance to the robot. There's also engineering work. Dulu itu social science. Sekarang engineers also ask people who already use our robot or use our system how they feel, how satisfied they are with our system, how can we improve more. So we also conduct this kind of questions to people. So apa yang kita akan buat hari ini is this. Okay. So I will introduce a bit of the robot. If we have time, we can go and meet my QT robot. I have to do that. Fully functioning. Tapi you will not be able to see the. Alright. Okay, I'm not sure my students ready ke tak. Tapi this is one of the robot that we have. This one can talk. Dia boleh cakap. Tu saya tak ada video. So kita nak tengok what is a robot. What makes a robot? Why we use robot? We look into the key components of robot is basically processor, sensors, actuators lah, and a combination of both. saya tak akan ajar processor sebab I think it's going to be very lengthy. So what is a robot? Okay. So a robot that we use in industry, houses, macam washing machine you, it's a robot. Your dryer is a robot, your dishwasher is a robot. Your automatic vacuum, robot vacuum, of course lah, the robot. So we actually live with robots. Kita tak sedar je. Okay. Your microwave is a robot. Okay. So these are a robot is something or a system that you can program or a machine that you can program. Okay. It has the capability of handling autonomous or semi-autonomous. Semi-autonomous. Not fun using other people's hands. So, basically, if you have your own robot, your own developed robot, you can program it to do various kind of things. So the robot that you have in your home, like your washing machine, your microwave, is a very standard robot. I mean, it has been programmed for specific tasks. But if you have your own robot, you have sensors needed for a certain task. You can program and reprogram according to what you want it to be. Okay. So, what we are discussing today, your robot is a machine that can be programmed for various tasks and is a versatile kind of robot. If you have like a line following robot, it can also act up as a sumo robot. It can also act up as a collaborative robot. But you have to reprogram it according to you. Okay, so your robot has to be equipped with sensing, which is sensors, intelligence, which is from your microprocessors, the computer in your robot, and mobility, which comes from your actuators, motor, arm, and others, right? So let's see what makes a robot. Okay, so what actually makes a robot? Okay, so robot pun ada qualification juga tau. Ada syarat-syarat nak jadi robot, bukan suka-suka je boleh declare ni robot tu robot kan. So it has to have, what does it have to have? Okay, you have to have sensing and perception. Yes, smart. Maknanya, there are many kinds of sensors, there are many categories of sensors, but it has to serve a purpose. So you have perhaps internal sensors just for the robot to identify where it is, what the temperature of the machine is, and so on. But there are also external sensors that is influenced by outside. So perhaps you have another type of temperature sensor to identify what is the temperature outside of the robot. Okay, so then you have to have this robot should be able to carry out different tasks. It can be reprogrammable and it functions autonomously to or interacts with human beings. So robot interact with human being is not they cakap hi, how are you kan? They interact, that means it can tell you what's wrong with it. So in order for it to happen, you have to build a circuit board that is filled up with LEDs, switches, what else? Perhaps LCD, so you can identify what's wrong. Okay, so circuitry lah. You all belajar advanced electronics kan? So kalau ada true and false, dia ada circuit dia yang boleh ni kan, you boleh guna PLC pun boleh, you nak guna apa lagi? You can gates boleh, okay? Switches kan? Boleh lah. So that is all the parts and parcels of your robot. So these are some examples of robot. Okay, so in industry we have manipulator type of robot. So like in Proton or Perodua, we have robot that angkat, the same angkat parts like, so robot yang besar-besar tadi dia ada sensors lah. So sensors, we'll be looking into sensors. I'm not going to talk about sensors. I mean we have for a robot to have senses. It has to be smart. Kau tak buat apa No point lah having a robot, betul tak? You nak robot cuci pinggan you, dishwasher you. Kan? You set temperature berapa, you set time berapa, soap level nak kena check, kan? You dah program dia akan ikut. Kalau tidak, you sendirilah kena measure berapa temperature air tu. You sendirilah kena pasang timer kat handphone ke, kat jam ke, tunggu jam dia nak bergerak kan. Might as well basuh tangan je. Kan? But you have machines that help you to make your life easier. Washing machine. Satu family anak 6 orang. Hari-hari basuh baju. Ingat banyak mana nak basuh? Oh. So, when you have washing machine, you set. Kalau yang sekarang ni ada set washing machine yang ada washer dryer. Kan? Inside there's a lot of intelligence. Water level tu satu sensor. Selalu machine top loading kita dulu tu water level je. Dan you program sikit lah, dia pusing, spin, dia air turun and so on. But now you have sensors that can check the water, whether it's clear or not. Dia pakai fuzzy logic. Tahu tak? Washing machine, fuzzy logic. Kan selalu orang jual washing machine ada fuzzy logic tu. Harga dia kat 1,000 lebih. Senang je sebenarnya, benda tu program je. Tak adalah susah sangat. Tapi sebab dia sebab fuzzy logic tu, wow. So, they have sensors to detect how clean the water is. So, kita dah campur sabun dengan baju kita kotor semua. When the water is clean, only then it goes to the next process. Sebab tu orang kata, mesin basuh fuzzy logic ni lambat. So, kalau air daripada air selama kotor kan, so lah. Banting. Tak ada air. Betul tak? Kan? Kena pasang water filter kan kalau. So, air masuk. Kalau air yang masuk terkeruh, berapa lama nak tunggu air tu jernih? So, sebab tu orang kata, washing machine tu slow. Bukan sebab machine tu slow. Air ni ada bersih. Pasal water filter settle lah. Sebab sensor tu kerja dia untuk check water tu. Measure the water clarity ke apa. I don't know what you call it. But so, that's why it's slow. And you nak spin. How long? Ada lagi satu sensor. Mungkin macam timer je lah. Tapi kalau you ada washer dryer, you have to program that robot, that machine, so that the robot knows that the clothes are ready to be dried. Kalau dia nak keringkan kain, tapi kain tu basah lagi, berair-air lagi, bila nak kering? Kan? So, ada sensor lain lagi. So, bila washing machine tu RM8,000, RM5,000, jangan terperanjat lah. Satu, kapasiti dia lagi besar washing machine tu, dia pakai motor besar, lagi powerful. Sensor dalam tu mungkin kena lagi banyak. So, very add some marketing and so on lah. So, but I'm just talking about the technology they use. So, like washer, dryer, washing machines, machine have more sensors, have more actuators, more programming logics. Belajar digital logic kan? 1010, so it works on 10. So your processor also actually works on 10. So you tak sedar sebab you type. So what actually is perceived by your processor is not load, clear, tak. Perkataan load tu dia ada ASCII code dia sendiri. Perkataan clear tu dia ada code dia sendiri. So dia akan work on codes. Dia bukan work on what you write. What you write on the computer is just to make your life easier. So can you imagine you work in hexadecimal number coding? Buat flowchart pun kita dah pening kan? You want to work in hexadecimal number? Mantap lah kan? Hexadecimal number, you break it up jadi what number? Binary number. Ones and zeros. Actually, hexadecimal is actually just to make your life easier also. What actually the computer or your processor knows is your ones and zeros. Okay? So, saya dah campur lah. So, like your washing machine just now, your robot have sets of different sensors. Different sensors have different purposes, as I mentioned just now. So, a sensor-driven robot or machine, it has to be able to sense. So, that's why you have sensors. Then from that sensor information, sent to a processor, and this processor starts doing decision making. Stop washing machine, pause, run to the next process. Okay. And then you have actuators, or that information from your microprocessor is sent to your actuators for the next action. So you nak on alarm ke, you nak on the nak spin ke, nak spin ke, nak dry ke. I mean we're just talking about the washing machine lah. So for a sensor driven robot, you have to have this sensing act loop. Okay. So for robots, okay, we have sensors for sensing and measuring geometric and physical properties of robot and the surrounding environment. Okay. Alright, so you have sensors that can measure position. It can be linear position, it can be rotating. Okay. Orientation. Okay. Orientation mungkin macam GPS you. Where you are. Where to move next kan. Kiri kanan. To identify where is the kiblat. Dulu kita pakai compass kan. Last time we use compass. Now you can use it on your phone. But there's a sensor inside there that allows you. The sensor that is corresponding to your processor. And your processor ada apps lah, that's your interface. Human interface tu lain lah, not our concern. Okay. And then there are sensors that measure velocity, acceleration, distance, size, force, moment, temperature, luminance, weight. So there are various sensors for various applications. Sometimes one sensor can do 2 or 3 things. It's a matter of how you program it or how you arrange the circuit. You belajar advanced circuit kan? Advanced electronics. So those are a lot of kind of these sensors that we use. So in robots, so for a robot that has a lot of sensor, one of the features is to estimate the condition and environment of the robot. So it can be temperature sensor, it can be your IMU, it can be, what's IMU? Gyro tahu gyro? Gyro tahu kan? Okay, so maybe that robot is stationary, but is aware what is the temperature surrounding it. It's aware whether the lights are on or not. It depends on what you put in your sensor or on your robot. You can also, if you have the sensor to measure the location where you are. Okay, so it depends on what you put on your robot. Okay, so when you have a robot, the first thing when you build a robot, the idea is to how to run it smoothly. As much as possible, you want to have little interaction with the robot. The robot does most of the job. For instance, your robot vacuum. That's smooth. Yeah. And what if you have surfaces like this? Only then maybe you will have to pick up the robot and then position it right. But if it's just a flat surface, you just switch it on and then it does its job. When it's done, it goes back to its charging dock. So what does it need? It needs sensors, a lot of sensors. Dia perlu location sensor, navigator. Dia perlu ada obstacle. So infrared sensor. Right. And then dia perlu apa lagi? Ultrasonic sensor. Dia perlu temperature sensor. Why temperature sensor? It can be internal wise, overheating, or it can be also external wise. Okay, so it depends. So, alright. So when you have these sensors in this robot, and obviously in a robot you have a microprocessor, processor. So you will, with all this sensor information, it will allow your processor to do decisions, to make decisions and execute. So, like for instance, your vacuum mover, if it moves towards perhaps the oven is hot, is on. Perhaps there is a feature, or if you can also develop the feature where it goes back, it does not go near. Because people, okay? So not everything is tolerance handphone, okay? So again, robot ni with the processor is coded in such a way it knows what to do. So if this sensor goes on, then what? If then rules. If this, and this is high, what happens? Ingat tak? DLD? Digital So your processor will do that. Alright? Okay, so your sensors in robots, it should be able to give solutions. Efficient quality, fast response, to be accurate. Kalau tak accurate, what's the point? Okay? Macam welding robot, spray painting robot, if it's not accurate, then what happens? Spillage, casualty, waste, ROI tak dapat, ROI. And it's not cost effective lah. So, I think I did mention a bit of this. So there are two classifications of robot that I want to share with you. So, robot sensors. It's the internal sensors and the external sensors. So, internal sensor, I think I did mention, it's just for itself. It stops when the motor overheats. Okay, it stops when the temperature is high. It stops at this position and it goes back to that position because you have programmed it. So, it will measure its speed, how fast daya pecutan dia laju banyak mana. So if it's approaching to a certain speed or a certain acceleration, it will stop. It will stop or slow down or be steady. So it depends on how you program the process. Okay, and then the next one is the external sensor. It's for the robot to get data from outside. That might also affect the decision of the robot. So you might have cameras, optic lah kan. Then you will have range sensor, infrared, laser sensor, ultrasonic sensor, and then you might have contact and proximity sensor, photodiode, infrared detector, RFID, touch sensor. Touch sensor ni basically dia ada pump. It's a mechanical switch. So you pump, and then information sent to the processor and it reverse ke, it stops ke, depends lah. Alright, so kita tak nampak begitu. So let's look at several sensors that is used in robotics. Okay, so this is an example of robot. So kat robot tu kita ada camera, microphone is also a sensor, tahu kan? Dia boleh detect voice kan, suara bunyi kan. You have ultrasonic sensor, you have inertial sensors, angle sensors. So angle sensor ni kalau robot tu humanoid robot, how much the arm can rotate? Kan nak rotate 360. Manusia pun tak boleh 360 kan? So humanoid robot, that means what does it mean? The robot has to be like human lah. Kan? As much as possible. Okay, so dia ada pressure sensor. Kenapa dia perlu ada pressure sensor? Kenapa dia perlu ada pressure sensor? Kalau ada orang certain parts of the robot is soft ataupun hard, and then perhaps for impacts, kalau dia jatuh ke, dia terlanggar ke, ataupun orang langgar dia, robot ni dia nak langgar orang mungkin very low lah sebab dia dah code ada obstacle avoidance semua. Tapi kalau orang ini swing a tennis ball to it, it cannot predict kan. So sometimes pressure sensor is there but not really utilized lah, but it's there for safety reasons. Depending on the manufacturer, you know apa. The temperature sensor, and then you have tactile sensor normally for your fingers lah. Robotic arm. Pernah nampak tak robot yang pick up telur? Kan? So dia ada tactile sensor itu, dia nak tahu when to stop. Kalau robot biasa crack lah. Kan? So kena ada sensor. Okay, so I've selected several sensors. But before that, do you have anything to ask? So if you don't ask anything, I'll just cakap je. Right? So, kalau cakap sejam pun tak apa. Kalau orang tak faham, dia diam je. So I assume no news is good news, kan? Tak ada tanya apa-apa, so okay lah. If you have anything to ask, just ask. Okay, so you have position sensors. Nak tengok potentiometer? Tak pernah kan. So potentiometer basically it works on resistors lah. So you have your wiper here, which is your sliding lah. Your sliding, and how far the wiper moves with the resistance calculation. It makes you identify lah where your robot is or where your actuator is. Okay. And then you also have encoders. Encoder pernah tengok kan? How does an encoder work? Tak tahu. Belajar kan? Encoder is used to measure positions, especially rotations. Okay, so you have what you have here is actually light source. So you have a light source here. Now saya pun tak nampak. So you have a light source here. Then you have a photo detector that receives the light source. And then you have a disc here that rotates. So hitam is 0, white is 1. So itulah code dia. So the more the black and white, what do you call it, black and white on the disc, more precise lah. So makin banyak lah dia punya, katalah kalau yang this one is very few, you can detect rotation of 50 degree, 30, 45, 60. Tapi kalau if this is finer, maybe can go by 1 degree. So lagi precise lah robot you. So humanoid robot have a lot of optical encoders. Encoder sini sebab yalah bergerak sini semua, sini semua bergerak kan. So you need encoders, right? Okay, and then you have light sensors, you have photo resistor, ni biasa tengok kan. Buat IoT farm lah, IoT garden, mesti kan guna benda-benda ni kan. You have photovoltaic cells, you convert solar radiation into electrical energy. Okay, so solar robot use this a lot. Vertical farm smart farming pun banyak guna. Okay. Temperature sensor. So this is like for external use of your robot. Okay, so we use extreme weather conditions. So you measure lah what is the extremity of the heat or the kalau luar negara kat musim sejuk, yeah, temperature dia. So you have actually IC packages where if the temperature itself is represented in voltage difference. So dia adalah reference voltage. Katalah you nak the room at 32 degree, 19 degrees for instance. So temperature luar dengan temperature dalam tu akan dibandingkan lah. And in air conditioners you have this. So kalau you ada aircon, tahu kan ada aircon yang boleh regulate balik temperature. So dia ada temperature sensor dalam tu. There are various kind of temperature sensor. So this is perhaps something you can buy over the counter, not something the industry might use. So you buka pintu, bekerja keras lah aircon you untuk tak pada 20 degree ataupun 90 degree. Kan? Tutup pintu, it's still 90. Kalau aircon yang dulu-dulu tu, you tutup pintu, sejuk lah, gigil-gigil kan. Temperature sensor ni yang bantu regulate balik. So the information is sent to the processor sends back information to the actuator or whatever system in the aircon supaya reduce the back temperature or increase the value of the. Just now I mentioned contact sensor. Okay. So this contact sensor, so dia biasanya ini macam dah terlambat lah. Dia dah hit and then dia retract back. So for non-critical things is okay lah. For non-critical application tak apalah. But if you have critical applications, you cannot afford for that robot to hit the wall, then you might not want to use this lah. So you might want to use a proximity sensor. Okay, so proximity sensor, I think that is right. So proximity sensor, proximity sensor is a sensor that can detect objects within predefined distance. So you boleh program. So you have various types of proximity sensors. So all sensors have their own range. So you have to look at lawan monitor ada object. Ini depending on sensor juga tak semua sensor boleh detect 1 meter. 1 meter is a bit far lah, 50 cm lah. 50 cm. So 50 cm and then
Dia bagi processor tak cakap apa-apa. So, robot tu jalan lagi. 25 cm. So, until at a point where robot kata, oh, lagi 5 cm. Kena berhenti. Ataupun kena belok kiri, belok kanan. So, that's what this proximity sensor use. Okay? It gives information. So, at a few, we have infrared, we have IR transceivers, we have ultrasonic sensor, photoresistors, all this fall under the proximity sensor. And then again, jadi robot tadi ada pressure sensor kan? So pressure sensor, it responds to touch, but not light kind of touch, a bit harder. Okay, pressure and force. Okay, so you can use this to design a robot hand to calculate the amount of grip and force necessary to clutch and jack. So basically, it's not very soft objects lah. Otak ke, kayu ke, holes to the sea ke kan. Because this is not very sensitive. But there are many other kind of pressure and force sensors. Okay, macam ni apa ni?
Listen bridge.
Listen bridge ni?
Tak nampak.
Strain gauge. Strain gauge. So what you have here is your force sensor. Okay, or your strain gauge ni is something that you normally use lah in sensors in force sensor. So kat sini kita ada wisdom bridge which is connected to your strain gauge, and then it will your wisdom bridge, your bridges here is connected to your bridges, so it can calculate the resistance difference, and then then after that obviously send to the microprocessor what it's supposed to do next. Lah. Okay, so when the force is applied on a fine wire that compresses and stretches it, its length change as a result, which in turn changes the resistance of that wire. Length and resistance of a wire are directly proportional to each other. So ni, this strain gauge ni sambung kepada you punya wisdom bridge tadi. Okay. Alright, and then you have, I think all of us have this, seen this, use this, navigation sensors. Robots need navigation sensors. Even that your vacuum robot needs navigation sensor. It might not be GPS, it can be localized. It can also be compass. So normally ada dua-dua lah, localization and compass sensors. GPS ni normally for bigger robots or smaller robots that works outside. Macam if you have a robot that is being used on terrain, or macam Boston Dynamics punya robot tu, dia nak bergerak ke kiri ke kanan, dia based on navigation sensor tu. So GPS lah. So it depends lah. Lagi mahal robot you, lagi canggih lah sensor you. Kan? Right. So then again, yes, you also have a robot. So robot ni dia tak stabil. How stable you stabil? Robot yang bergerak, 2 kaki ke 4 kaki, dia boleh jatuh. Melainkan kalau robot tu base dia besar, dia cuma guna kaki takai, dia guna tangan je dengan mulut. Speaker dengan arm. Ya, itu stable lah. Kan dia gerak macam tu je. Jadi kalau robot yang bergerak, moving robot, tendency to fall is there, right? Tendency to fall is there. So you need acceleration sensor where it's one type of sensor that can measure tilt and acceleration, but you also have gyroscope. Okay, the gyroscope can measure and help maintain orientation using the principle of angular momentum. Okay, it can measure the rate of rotation around a particular axis. So kalau depends on your application lah. So IMU sensor, lebih lagi, dia boleh measure velocity, orientation, gyroscope tadi boleh orientation kan, and gravitational force. So it combines the tilt sensor and the gyroscope sensor. So obviously IMU mahal lagi lah. Arduino pun kita selalu kalau you buat robot, if you processor you guna Arduino, you selalu akan ada IMU sensor lah. Right, so your IMU sensor measures velocity, orientation, gravitational force at the same time together. So it's very accurate and it's very useful. So your processor gets more information at one time rather than one by one. So the sensor, so the navigation, ada gyroscope, satu-satu kan, so dia terpaksa if then rules kat situ. So this one dah tak payah. Kat sini dah ada perhaps the information is given as 111, 110, dia dah ada table dia to identify what's the position. So, I think you've done this before. Kau belajar instrumentation kan? So, how you select sensors? You buka data sheet kan? So, you kena tengok accuracy dia kan? So, one sensor to another sensor, different models have different accuracy. So, depends on what you want. If you want high precision, tak boleh nak ambil low accuracy kan? Then, what is like deadband and hysteresis? What is it? And calibration. Is it easy to calibrate or not? So, itu by experience lah kan? And then repeatability. You use that sensor on that circuit 20 times, 30 times, you get the same results. Or plus minus 10%, depending again on the data sheet. So, some data sheet, dia kata lah plus minus 5% accuracy, yeah. So, you need to take into consideration the linearity, drift, temperature. So, all this is actually in the data sheet. So, for sensors, you will have all this in the data sheet. And before you select a sensor, you can use this information. Okay, so it depends. If you want to have something very high precision, then your sensors and actuators will be high end. Expensive lah. Okay, macam exoskeleton robot ataupun robot yang humanoid, motor dia mahal. So, dalam motor dia ada sensor sekali. Ada encoder dia sekali. Kalau you buat sendiri, kata tak nak lah nak buat sendiri, you kena beli encoder, motor, kena beli motor driver, combine everything, adalah besar ni. Tak kat tangan. Lebih bagus. Okay, so that's it lah. Technology moves fast. Dulu motor besar-besar. Besar-besar ni je. Kecil. Tapi powerful. High torque. Kan? But, yeah, as technology goes fast, maybe something that's expensive now will be cheaper. 5 years time. But at that time, there's something better than that. So, nak kerja tak boleh. Try lah kan? Alright, so then saya sudah sampai. Alright, so then we have actuators in robot. So, kita tahulah robot nak bergerak kena ada motor. Motor tu yang bergerak dia. Tapi sometimes the motor is attached at several angles, like contohnya humanoid robot atau exoskeleton. So the collaboration between the three robots, it has to be programmed together so that if you want to raise the hand, what's the angle of this motor? What's the angle of this motor? What's the angle of this motor? And what are these other 5? If you have fingers in your robot, so what these 5 fingers will do? So benda tu semua kena calculate lah. Dia adalah calculation dia. Right? Okay, so an actuator that is used in robot, it makes the wheels of the robot turn. So, biasalah robot yang mobile robot tu, tu actuator dia motor lah. Robot arm joints turn. So kalau dia nak gerak macam ni ke, so it's how you program the robot lah. And then you have the gripper of the robot, open and close. Okay, place. Okay, alright. So the working principle of a robot actuator is to change the energy into physical motion. It can be either linear or rotating. Okay, so linear motion ataupun rotary motion. Okay, so motor is it's a slightly complicated than sensors, but we only have very few types of motors. We have the hydraulic, we have the pneumatic, we have the rotary. Okay, tapi under the 3 of them, they have many other types lah, but they work on the same principle. Okay, sensors is not. We have many types of sensors. Okay, so let's see. So electric motors or electric actuators, okay, it converts electrical energy into mechanical motion. So you choose a motor due to what? The speed, precision, torque, ease of control. But the robot susah nak control. Robot motor, okay? So it depends on what's your application. So the top one is what motor is? DC motor. Ini motor apa ni? Stepper. Servo. Ini stepper. The stepper dan actuators, it's not that it's not used in robots. Used a lot, but in bigger robots. Because hydraulic actuators are big. berat, big, and also messy lah, a bit messy. So macam kukar robot tu adalah hydraulic sikit. Okay, dekat face dia tu. Okay, so, but hydraulic actuators give high force and power. Dia lebih kuat daripada DC motor. That means a DC motor that wants to work on par as a hydraulic actuator, you might need a very big motor. Hydraulic tak besar sangat lah compare to ni. And then kat sini kena Pascal law, dah tahu apa Pascal law apa. So you have your hydraulic actuator. It comes fluid, pressurized fluid, ammonia, to move a piston. So advantage dia high force, high power. For heavy lifting, robot-robot yang angkat big box, angkat container. So that one will be on hydraulic actuators. It's robust. Dia tak adalah kekal sana sini tak rosak, tak senang rosak. Tetapi the system is complex. Maintenance is expensive. Okay? And it's less precise. So again, selecting your actuator depends. How precise you? Electric motors are precise. Hydraulic less. But when you come to pneumatic angin angin. Okay? So it compress air. Compress air to generate motion. Memang tak dengar brake angin. Right. Kalau kereta depan tu brake emergency, dia sempat tak nak brake kalau dia follow dekat? Tak sempat. Sama lah macam so if you want, katalah you nak move point to point and it has to be precise, pneumatic is not going to be your choice. Hydraulic maybe boleh lagi. Kalau you bagi tolerance. Kalau pneumatic, you harus bagi tolerance tinggi. Maknanya tak boleh ni lah. Tak boleh nak guna untuk short range movements. So the advantage is what? It can use to perform variety tasks, like from moving a robotic arm to driving a wheel. Kereta lah, bukan kereta. Lori, truck, banyak. It's not precise. Again, it is complex. Kalau gunakan robot, it's complex. Sekarang pakai apa? Fluid. Tapi bukan hydraulic. Bukan hydraulic. Dia kena kalau dia minyak tidak kurang dan dia tak smooth kan. Itu masuk otomatik pula kan. So, when you want to select, ni cikgu kena dengar lah bila nak buat projek, macam mana nak pilih actuator. So, dia nak buat robot ni. So, kita, ialah budak-budak kan, pandai sangat lagi kan. So, kita lah kena tahulah what kind of force and torque you need. What is the application of your robot going to do. Okay, kalau mobile robot tak susah sangat lah. Tapi maybe in 10 times you don't do mobile robots anymore. You don't know. Right? So you are going to be, in 10 years times, you're going to be the lecturer for cikgu for technology. Yeah? So what kind of accuracy? Okay? What is the speed? Kadang setengah robot, dia laju. Okay? Dia laju. Tapi when something happens, kata ada obstacle ke, ada dinding ke, respon pada tu dia nak slow tu lambat, ataupun dia nak reverse lambat, ataupun dia langgar dulu, itu baru dia decide nak buat apa. So you have to decide lah what type of robot you nak buat. So how efficient? So mungkin motor sekarang dah kecil-kecil. Check on the data sheet. Kadang beza RM10, RM20. Beza RM20 dapat high accuracy. Things tu you nak pitch ke, you nak buka club stem, you nak buka club robotik, nak beli motor macam mana? Cikgu kena baca manual lah. The durability, reliability, so kita kalau beli barang, kita nak benda tu tahan lama lah. Tak nak lah hari ni beli, minggu depan dah rosak tu kan. Especially when you are dealing with high purchase. Berapa lama you nak guna benda tu? 5 years, 10 years. Kalau nak bawa student pergi competition, robot tu kena durable lah. A durable robot is a robot that has good components. Okay? So components tu you calculate lah berapa berat robot you. Berapa motor tu boleh tanggung ke tak boleh. Maybe you might need to do some simulations. Or calculation pun boleh pun. selalu motor tu dia boleh tampung berapa. Okay. So size and weight semua tu adalah effect pada your robotic application. Okay, any question? Mana yang before this tu? Yang tadi tu. What is it? Ni. Datasheet lah, robot motor tu adalah datasheet. Macam sensor juga lah.
Ada main point tu kita tengok nak tengok dulu baru kita tengok video kita.
Oh, so normally kalau saya lah, we are talking about medium size robot. First I have to identify what my robot is going to be. How robust I want my robot, how accurate I want my robot to be. Then I will think of the weight. If the weight is very light and your application is big, then the robot is not going to be able to manage that weight. So you have to think before. So you have to add some tolerance there. And then you dah letak sensor, letak motor, letak gear apa semua. Berat satu-satu tu mungkin berbeza, tapi bila combine dengan base, tambah lagi berat dia. Motor kita boleh tahan tak? Kereta kita boleh tahan tak? Kan? Tentu kalau you buat exoskeleton, arm joint. Kalau robot tu memang you plan untuk robot tu jenis swing macam tu, so robot kat sini dia robot yang quality robot. High precision, durable, dan daya ketahanan dia kuat lah. Kalau tak, if this here does not work, then how the rest of the limbs going to work? Right? So you have to take into consideration and reliability. Reliability depends on your design juga. Maybe the motor is a very good motor, tapi the weight you put on the motor, kan? Kan? You kata, oh motor tak bagus. Tapi you salah kalkulate. Kena hati-hati. Alright? So, small robot okay lah. When you going to bigger robot, macam hari tu nak masuk robot farm. Robot nak robot besar. Tak boleh pakai motor kecil-kecil. So, reliability macam mana? Accuracy macam mana? Semua tu kena study lah. Right? So, saya buat malam tadi tapi dah jadi. Saya besar pun. So, this is an example of a vacuum robot. Because I don't keep on saying vacuum robot. Yeah. Sebab 50% of household have vacuum robot. My house tak ada lagi. Sebab saya ada anak-anak yang boleh vacuum. Once they're out of the house, I'll buy one robot. So, robot ni dia ada sensors. Okay? Dia kena ada sensor. And then robot tu bulat. Where you going to locate this? Itulah saya pun tak tahu kenapa dia bulat. Saya pun tak tahu kenapa dia bulat. Tapi kalau segi empat kenapa tak boleh? Agak-agak kenapa?
Cleaning dia doktor.
Corners. Jadi bila bulat ni, benda bulat dia bergerak tu dia kurang geseran, kurang bumping. Kan macam go wall to wall. Kalau square tu lagi susah kot nak maneuver. Bulat tu dia boleh rotate, pusing-pusing kan. Dan bucu dia tak tajam. Ataupun dia tak mengganggu lah. That's my opinion. I didn't read any papers on that. So, saya tak tahu. But logically lah. Bulat nampak cantik lagi. Comel. So, aesthetic lah. So, what do we have here? These parts work in tandem to tackle tile, hardwood, floors, carpet, and anything in between. So, ni vacuum robot ni lah. So, dia dah study. Sebelum dia buat robot ni, dia nak buat robot vacuum. Tapi tak logik lah kalau dia buat untuk rumah yang ada carpet je. Dia vacuum carpet je. Kalau rumah yang tak ada carpet je, saya lantai macam ni. Dia nak jaga reputation tu, dia ada better features lah. Better sensors, actuators. So, robot ni vacuum based apa kita nampak. Robot ni dia guna infrared sensor, dia guna photocell sensor untuk navigate around the room. Okay. And then there's also cliff sensor. So cliff sensor ni kat sini lah. Supaya dia tak jatuh. So dia ada range of motion yang dibenarkan. So macam mana detect? Mungkin sensor punya range mencapai macam ni, tapi dia ada juga boleh detect kawasan sini. So dia tahulah, oh sini kalau lalu lagi boleh jatuh. So that's cliff sensor. So cliff sensor I think it's not widely used other than in this vacuum robot. I cannot think of other applications. Okay, and then there's also wall sensor. Wall sensor tu lebih kurang macam bump sensor juga, ataupun proximity sensor. It's a type of proximity sensor. Dia allow lah robot tu berapa cm daripada dinding. Kalau jauh sangat kan dia tak cuci, dia tak vacuum pula di tepi-tepi dinding tu kan. And then what else it has? Bump sensor, of course. Basically itulah. So robot yang saya ambil contoh ni nama dia Roomba. Tak sure ada lagi ke tak? Ada ke? Dalam? Saya tak sure. Saya tak check. Alright. Okay, and then siapa boleh? Who can give me an example of a robot sensor that is similar to human sensor?
Robot sensor tu lah. Temperature sensor.
Mana the feature in the robot, a sensor-based feature on the robot that we have.
Temperature sensor.
Kita ada berapa sensors? How many sensors? Five sensors. Touch,
Touch. Taste. Smell.
okay.
Taste.
Taste,
Hear.
feel,
Sight. Sight.
sight. Mata So robot ada. Sight ada. Dia pakai kamera. Microphone. Pressure. Apa tadi? Temperature sensor dan heat kan. So you can actually have humanoid robot that can use all these five senses we have. But normally because kita ada processor yang sangat hebat dalam kepala kita ni, so sometimes we only need five sensors kita. Tapi bila robot kita kena tambah. So macam kita rasa heat, tapi kulit kita ni semua dia bercantum kan. Kulit bercantum, so kita rasa panas. Kalau kabel tu dari depan, belakang pun kita rasa panas kan. Tapi robot tak macam tu. So you have to place various temperature sensors on the robot if needed. And then apa lagi? Touch. Smell. Hijau asap. Smoke detector. Yeah. So these are the, how to say, you will not get a robot that is 70%, 50% like a human with minimal sensors. So for it to have that five senses like a human, you have to have a lot of senses. Then that has not even included decision making yet. So ada AI lah kat situ, artificial intelligence. So what are the features of artificial intelligence? So you kena study lah tu. So kalau you nak buat satu robot yang kecil tapi ada five sensors, mungkin senang lah. Tapi kalau you nak buat humanoid robot, macam mana pula? It's going to be more lah. So that's why robots are expensive. But it is useful. It's worth the investment. When you teach your students STEM, I would recommend go with robotics. Then you break out the robot, tunjuk satu-satu sensor. Janganlah masuk calculation. Memang lari lah budak kan. So but to get them, and then bila you ajar physics, because you're teaching physics, right? So what are the elements in physics that you can use on that robot? Acceleration, velocity, motor, gears, semua ada kan calculation tu kan. But you let them make the robot first, fine. But after that, you break satu-satu. So, like for us, kami di UAE, when we go out, we reach out, we don't have time for that. We don't have time for that, so kami ajar robot je. Memang pasal robot je dah 2 hari. Nak compete lagi. Sekolah suka competition. So we have to compete. So kita tak sempat nak ajar the mathematics, the physics. So when you guys are in school and in the STEM club ke apa, you try to incorporate physics. Supaya dia orang suka physics. Selalu saya tengok kalau STEM option mesti dia buang physics. Ambil biochemistry. Kan? Mana di kelas fisik, sebab kelas anak saya tu, the whole class is about 30 kids and they're all in science stream. But when it comes to physics class, tinggal 10 orang. Yang lain tu ambil, saya tak tahu lah dia ambil apa, tapi tak ada lah. Mungkin dia tak ambil another subject, tak ambil one subject, dia ganti dengan benda lain ataupun dia tak ganti. But we need a lot of engineers. We need scientists. We need spacecraft engineers. We need physics lecturers. We need, because without physics, robots will not happen. My lecturer, his background, his undergraduate degree was physics. His PhD was in robotics. That was in 70s. 70s tu mana ada mechatronic, mana ada electrical engineering, semua bawa fizik. Physics maths kan. Lepas tu dia pecah lah because dia nak lagi specialize masuk engineering lah semua kan. So if we can get kids to like physics plus the maths physics tak boleh lari dari maths kan, it will be an achievement for all of you. Sebab kami hanya boleh pergi kat 3 hari, tapi kalau you cikgu fizik boleh sambung, memang cantik lah. I hope one day we will cross path. Kami kat UAIM memang mampu hantar robot je lah, ajar robot saja. You come up with the physics. We can work together hand in hand. Buat modul tak ada masalah. Kalau you dapat final project FYP nak go into STEM and physics through robotics. That's an idea. Tapi dia you kena buat. I don't know what's your FYP like, but it's an idea. So STEM, robotics, learning physics, understanding physics. Yes. So I'm done. So I hope the first part. Kalau saya tak ingat awak, tegur lah saya. Okay. If you want to come here, nak buat internship, boleh. Kita dekat CUBE boleh buat internship. So you can join the STEM team for internship, or you can join the industry for internship. I tak tahu you want internship kena pergi sekolah ke, I tak tahu. Sekolah. So maybe you can promote UAE, we do robotics together, or UPSI and UAE go together. Buat budak datang UAE, yes, our makers is memang untuk orang datang. Cuma dia kosong lah, kita kena buat workshop lah. So last time we put a lot of things there, lepas tu hilang. Humans are humans lah kan. So alright, I'm done. Any questions? I'm sorry because if I speak, at times I don't give chance for other people to ask questions. Sebab dia tak angkat tangan, saya anggap tak ada apa-apa lah, tak ada soalan. Yang saya memang macam itu.
Exoskeleton nak buat bionic kan kita takkan so macam mana dia nak generate
bateri tu bukan dekat situ lah. Bateri tu nanti dia akan ada satu bateri tak kecil je lipo, jadi kena ada bateri tu lah. It has to be checked. Tapi if it's a product, the manufacturer can somehow customize it with any other ways. Kalau kita pakai barang over the counter, memang restricted lah. You akan nampak lah lipo bateri disusun. Tapi kalau you, if it's a prototype and it's going to be used on human, definitely the battery pack will not be there. So it might be powered. It's like it's inside ke apa supaya it will not restrict the patient's movement. So it's another engineering field which is called